unmute myself. Okay, great. Thank you so much. I really appreciate that introduction, and I'm really pleased to be here. In fact, I just got a message from someone who had seen a recording, and the message said it was awesome. Your presentation and the content was so amazing. I'm sharing this with my instructors and TAs to see if we can integrate it into our introductory course. And so, what a way to start a plenary by getting that kind of message. So I really appreciate that. And as I said, I'm really pleased to be with you this morning. The last time I was at North Carolina State was in the early 2000s when I was doing an on-site National Science Foundation visit, and had a great time then. And I'm really happy to be with you today to share something that I have become passionate about. Let me see if I can share my screen here. And oh, yes, share sound is on. That I have been passionate about only for about the past 20 years or so, because I didn't know the things that we're going to be talking about this morning, metacognition, before I got to LSU. And I've been teaching for about 30 years before I got to LSU, and I started LSU 20 years ago. Now, I have to tell you, if anybody's getting my age from that, 50 years, I started teaching when I was 5 years old. So I'm not quite as old as you might think, given those years. But in any event, I have really learned that this can be a game changer for students. And so this is what we're going to be sharing this morning. And I am going to use the chat box. This is going to be a participatory plenary. And so please make sure that your down arrow is to everyone in the meeting so everybody can see everyone else's responses. So feel free to make comments. I ask a lot of questions. There are no right or wrong answers to any of the questions I ask. I just want to know what your experience has been and what you're thinking. And I really want to thank the Office of Faculty Development and Diane for inviting me to do this, celebrating faculty success and resilience. And I've looked at the amazing program you have, and I was hoping to at least be able to participate in the roundtables, but I'm going to have to dash off after the plenary because the National College Learning Center Association is having our annual meeting today, and I'm going to have to join them right after the plenary. But thank you for all that you do. I tell faculty all the time that it's just amazing what you're doing in this particular time. I retired from LSU in 2013, and I do not think I could do what you are doing right now. And obviously, your students appreciate it. I saw the many faculty whose names were listed in Thank a Faculty Member. And so I just want to add my thanks for what you're doing. And also looking at the QEP, and I know you're finishing one cycle of it, but I think you're continuing the effort on Think to develop higher order critical and creative thinking skills among your students. And outcome D, students will reflect on their own thinking and the thinking of others. And of course, that's exactly what metacognition is, thinking about your own thinking. And I think that faculty success and resilience is really so connected to student success and resilience that what we're going to be talking about today is how we can help our students be more successful and more resilient. And then that really helps us. Because I talk with so many faculty who, when students are not doing well, they really are trying to figure out, what can I do to help students do a lot better? And I know when I was teaching, it really brought me down. If I gave a test and everybody failed, it's like, what was I doing these past 3 weeks? Didn't anybody learn anything? But then when students were doing well, then it made a big difference. And so what we're going to be talking about is strategies that you can teach students that will make an immediate and dramatic impact in their success and their resilience. And I say metacognition is the key to that. And so metacognition is just your ability to think about your own thinking. Just very simply put, there are many more sophisticated definitions. But when I talk with students and I want them to actually do something with the information, then I try to make it as simple as possible so that they really understand the concept. And so when I talk to students about metacognition, I say, it's as if you have a big brain outside your brain looking at what your brain is doing. And that big brain is asking your brain, did she just memorize this information last night because the test is today? Or did she really learn it? Did she concentrate on understanding it? It's saying if she's got a paper to write, does she realize that she needs to start early? She needs to think about what she's going to write about. She needs to go to the writing center and get their input about her ideas. She needs to develop a draft early enough so that she can share it with the professor, get feedback, and make some changes so that when she turns the final version in, it's going to be as good as possible. Or is she just planning to whip it out the night before the way she did in high school? It's your ability to be consciously aware that you are a problem solver so that when things come up, you don't have to get somebody else to answer all of your questions. You can start to think about how could I answer my own question? And an example of that, and here's your first question for the chat box, please. An example of that is if we think about it, most of the questions that students ask us about our courses, where could they find that information? Just put that in the chat box for me, please. Because they come up, oh, I see. Okay, what's happening is I've got to scroll down. You're typing messages that I don't. Exactly, I see the syllabus. Exactly, Moodle, the management system. Yeah, there are places that students can go. And so if a student is not using their metacognitive brain, they'll think, oh, I wonder when the next test is going to be. I'll have to ask the professor. And then the metacognitive brain says, we can answer that question. And so then the brain says, well, what am I supposed to do? And the metacognitive brain says, well, what resources did our instructor give us that might have the answer to that question? And so it leads them to the resources. And so they realize that there are things that they can answer themselves and they don't have to ask somebody else. It's your ability to plan, monitor, and control your mental processing so you know if you're understanding something or if you're not. And it's your ability to accurately judge your level of learning. And that is really, really important because, oh, I see a comment. I explain metacognition students as having them stand behind themselves, yes, and look over their own shoulder and comment on what they're doing. That's an excellent way of doing that so that they really intuitively understand what metacognition is. Now, in terms of accurately judging your level of learning, that is huge because whenever I talk with students, if I'm at a campus, I will ask them, how many of you have ever heard a professor say something like, this is the university now, you got to kick it up a notch. We operate at higher levels. This is not high school anymore. And all the heads go, yes, hands go up. And so they said they've all heard professors make this kind of statement. I said, yeah, we love making statements like that. And then I'll ask, who thinks you can tell me exactly what those professors mean when they say you got to kick it up a notch, we operate at higher levels here? And very, very few hands go up. But the ones that do, they'll say things like, oh, they mean that it's going to be harder in college than it was in high school. They'll say, oh, that means that we have to do more work. Sometimes they say we have to take more responsibility for our own learning. We have to have a great work ethic. And I say, yes, all of those things are true, but they're talking about something else also. And I ask students, how many of you have heard of Bloom's taxonomy? And almost no students have. And so here's a question for the chat box. I know Bloom's taxonomy, when I first started doing these talks about 20 years ago, very few faculty had heard of Bloom's. But now that I know you're part of SACS, COC, and so we have to write these student learning outcomes, and many of us tie them to Bloom's. And so just put in the chat box for me, please, either yes or no. Would you say you are very familiar with Bloom's taxonomy? And okay, yes, I'm seeing lots of yeses. And someplace I talked, yeah, I see a very, it's one person said, I'm bloomed out. I'm all bloomed out. And so most of us know, and it's okay if you haven't because we're going to talk about it. But now let me ask this, since most of us are familiar with Bloom's, just tell me yes or no. Have you actively taught Bloom's taxonomy to your students, to the students in your class? This is yes or no. Okay, I'm seeing some yeses. I'm seeing lots of no's. I'm seeing a plan on it. Okay, sometimes not really. Yes. Okay, well, and I'm going to urge all of us to actively teach Bloom's taxonomy to our students. Now, I understand those of us who were not, because I never taught Bloom's to students before I got to LSU. But when I got to LSU, they were teaching Bloom's to students very successfully. And so I started doing it. And the most common reaction I would get from a student when we talked about Bloom's, they would say, wow, why didn't anybody teach me this before? I wish I had known about this in high school. And so I really encourage us to do it, and I'll show you the way I do it. But I think that what happens is Bloom's taxonomy, I think, is the lens through which our students have to view that statement. We operate at higher levels now to see exactly what we mean. If they have no idea that there are any levels out there, then they have no idea what we're talking about. And so I have a comment here. Okay, a mix of approachable, reminder of the info you need might be there. That's helped me get more questions about content that are interesting versus, yeah, when is that due kinds of questions. Exactly. Yeah, sometimes I call this talk, get students to focus on learning instead of grades. Metacognition is the key. And I also find that when students know this information, then they see now how their learning will determine their grade, and they know what the difference is. And so, yes, so I'm going to urge all of us to teach our students about Bloom's taxonomy. And it's your ability to know what you know and what you don't know. So you don't show up at a test or a quiz thinking, okay, I studied all night, I know this stuff, I'm good. And then you look at the first two questions and it's like, uh-oh, I guess I don't know this stuff. Well, when I learned about, the idea of metacognition, metacognitive skills, these things almost sound like, well, they're kind of second nature. Why don't students know this? And it's because it really wasn't necessary before. These are data from the UCLA Higher Education Research Institute, and every year they survey first-year students all over the country, different types of institutions, and they ask a lot of questions on this instrument, but I am particularly interested in the answers to two. One is the amount of time that students spent doing any homework at all in 12th grade, and the other is the average that they had when they graduated from high school. And what you'll notice is that the percent doing even 6 hours a week on homework, that has never reached 45%. It was up to 44.8% in 2015, and it hovers around in the low 40s. But the percent who graduated with an A average, that number actually crossed 50% in 2013. And in 2015, it had reached a high of 58.7, and then it started going down. And I was wondering when it went down to 51.5, it was going to continue to go down. But as you see in 2018, 57.6, 2019, the last year for which these were available, 59.3. And so what this says is that our students are not having to do any homework at all in 12th grade, but they're making A's. And so I always say that our students are just being good scientists. They are taking all of the data points that they've accumulated up to this point in time, and they're basing their actions on their data points. And what their data points say is, I don't have to do anything for homework, and I'm still going to be fine. And so I really also got a much better picture of exactly what was going on with students when I first asked a set of students at LSU, and I'm going to ask you to put in the chat box. And now I've asked it to students all over the country, other countries also, and the answers are remarkably consistent. And so I want you to put in the chat box what you think students said when I asked, what did most of your teachers in high school do the day before the test, the class period before the test? What do you think most students said? Exactly, review. Absolutely. I totally expected that. But I was blown away by the answer to the next question. I asked the students, what did the teachers do during the review session? And put in the chat box what you think. Yes, Donna told them the answers. Yeah, and so Jeffrey again, go over the answers for the test. Now, I was shocked because I thought they were going to say, well, they told us the topics that were going to be on the test and we reviewed those. And I was all set to say, yes, but we don't do that at the university. You have to do that yourself. But when they said, well, they gave us the questions and the answers, it's like, oh, okay. And so then I asked, well, if you'd never gone to class a single day before, just the class period before the test, and you went to class that day and you paid really close attention, what's the lowest score you would have made on the test the next day? And put in, okay, I'm seeing an 80. Yeah, what letter grade? I was asking them. Okay, yeah, a few of them said A, a few of them said C, but most of them said B. And so that's when I realized that we as faculty are going to have to help students make this transition. Now, there was an article that came out in September of 2019, The Dangers of Fluent Lectures. And basically what this article is about is we as faculty, we love to do active learning, but students think that they are learning less in an active learning situation than if they're in a classroom with a lecturer who's very fluent. They have this perception that they are understanding and they really don't. And so I like to share this with faculty because I think that it is really, okay, never seen anything like this, teaching to the test in Germany. Okay, I'll take 30 seconds and address that comment. But I think that we've got to share with students. Of course, what the research says is that the opposite is true. Students learn a lot more in active learning, but they just perceive that they're learning less. And I think it's important for us to share with students the research that says that in the active learning setting, they will learn more. And we could even ask them, why do you think that might be the case? And have them participate in that, because I love doing this by reflection. Now, the reason that teachers in the U.S. teach to the test is because we've made those scores on tests so high stakes, where teachers' raises, whether or not they're going to have a school next year, whether or not they're going to have a job next year, is dependent upon the grades that students make on those tests. And sometimes principals tell them, because the standing of the school is based on that too, principals will tell them that they have to do this in order to get the scores higher. Hopefully that's going to be changing at some point, but sadly, it's not the case now. So as I said, what that means is we as faculty have to help students make that transition from what they're doing now that is not leading to the appropriate amount of learning and lower grades, and what they need to be doing that will lead to desired learning and desired grades. And you have an extremely valuable resource there at North Carolina State, the Academic Success Center. And they're facilitating degree completion by providing a comprehensive variety of free programs and resources, promoting academic skill development and independent learning. And so the things that we're talking about today, they know at your Academic Success Center. So I highly recommend that. And so now what I want to do is just take a second to go over the questions that I ask students that really will help them to understand the difference between what they've been doing and what they need to do. And so I'm just going to take probably just have time for the first couple of answers in the chat box. But and I'm not asking you what you think your students would say, but how would you characterize the difference between studying and learning? How would you describe the difference between studying and learning? And I see we're getting some great comments in the chat, and hopefully this will be saved with the recording, so when you go back, you can see those great comments. But if somebody could put in the chat box, how would you characterize the difference between studying and learning? Because there are actually 3 common answers I get from students. It's remarkably consistent. Studying is building knowledge, learning is applying knowledge, memorization, learning, making connections, okay. And it's interesting, they typically don't say that studying is building knowledge. They will say studying is applying. But yeah, they will say, and I'm seeing it come across in the chat box, the 3 most common answers, they'll say, yeah, and I see that this is short-term versus long-term. But the first thing they say is they'll say, studying is just memorizing information for a test or a quiz, whereas learning is understanding that information, being able to apply it, being able to relate it to what I already know. Sometimes they'll say studying is short-term, learning is long-term. Sometimes they'll say studying is tedious, learning is fun. But when we establish that difference between just memorizing information for a test or a quiz and really understanding it deeply, and I ask them, okay, if we look at that as the difference, up to this point, would you say you have more often been operating in study mode or in learn mode? And put in the chat box what you think they tell me. They've been in study mode or learn mode. Study, absolutely. Now, before we ask them this question as a reflection question, they've never thought about this. Nobody's ever posed this to them, but they'll say they're in study mode. And then the second question, I posed 2 scenarios and asked if they would work harder. If I came to them as a professor and said, look, we are having the next test in this exam next week, and you failed the first one, and so you have to make an A on the next one if you're going to do well in this course, you know how hard you'd work for that. Second scenario, I come to you as a professor and I say, look, we're going to have the next test in this class next week, and it turns out that the class did horribly, so I see now I'm going to have to do what everybody wanted me to do before the first test, and I refused to do it. Everybody said, are you going to give us a review session? And I said, no, we don't do that in college, but the class did horribly, and so I say I'm going to have to offer a review session, so I'm going to do that the class period before the next test, and you are going to teach that review session. I'm going to have you come up to the front of the class without any notes or anything, and you're going to go over all the important concepts, paying particular attention to the more difficult concepts to make sure everybody is prepared for the test the next day. Would you work harder for A or B? So please put in the chat box if you would work harder for A or B. Okay, yes, I see a lot of B's, and this is what students say. And why would you work harder for B? And I ask you just put in the chat box, why would you work harder? And I'll see if your answers mirror what the students say. Because again, yeah, that's one of them. Peer pressure, feel response. Okay, yeah, you got it. The main three are, they say, well, I have to really understand it if I have to teach it. They'll say, I don't want to look stupid in front of the class. So there's this peer pressure. And then some of them say, well, now that everybody's grade is dependent on what I do, I want to make sure that I can explain it more than one way. I can use charts, I can use diagrams, etc. And so then I asked, well, yeah, this is great, but up to this point, have you been more in scenario A mode or scenario B mode? And just put in the chat box what you think they tell me. Once they know, yeah, exactly. And I said, wonderful. I love it when you're doing everything wrong, because that means that the prognosis for improvement is great. Because it's really not our students' fault that they are doing everything wrong. They don't know to do anything differently. And I just wanted to show you the results. This is the other thing. I love to show students results of these strategies. There was a young man I met when I gave just an hour presentation to a chemistry class. And before the presentation, he'd made a 66 and a 62 on his first bio and chem exams. And then after, he went up to 98 in bio, 83 in chem, B in both courses. And I asked him to send me an email. Oh, he came up after the session and he said he had a beta fish in his room and he was going to teach the strategies to teach the material to his beta fish. And so he sent me an email, and I'm going to ask you to ask your students, because everybody in this session has had students who were not doing well, and then they came to you and they started doing a lot better. But if you're like me, you never ask those students to tell me what you're doing differently. And so ask them to send you an email and tell you, because sharing those emails with other students is really helpful. So he started attending more of the SI sessions, and I see you have SI sessions at North Carolina State. And before he heard this talk, he was just going to the sessions not really having prepared. But after the talk, he would try to answer as many questions as he could before he went to the session. So he knew where he was in the session. He knew what he really needed to understand. And then after those sessions, he'd go to his room and teach the materials to his beta fish. And anything he couldn't explain, he'd study more. And he continued that cycle until he could explain everything in his notes. And so that really made a big difference for him. And so now I want to share with you just a couple of other strategies that made the difference for a student in psychology where reading was a problem, and a student in physics where the way she was doing her homework was a problem. And Travis had made 47.52 on the first two tests. Talked to him 30 minutes the night before the third test, 82, then went up to 86. And basically what I taught him was a reading strategy that it just involves previewing the text before you read, developing questions that you think the reading is going to answer, then read one paragraph at a time while you're paraphrasing the information. In other words, developing that anticipatory set before you start to read. And so what I want to do now is just a little activity. Some of you may have seen this, so if you have, don't put the answer in the chat box. But I'm going to put a passage up, and I'm going to give you a minute or so to read it and ask you a question about it after you've read it. Okay, I'm going to take it off. And yeah, some people said, not very accessible, all caps, is yelling, absolutely. But if you haven't seen this before, does anybody think that you would be able to summarize the information in that passage? Just put yes or no for me, please. And yeah, okay, no. But now, if you had known before you started to read that this passage was about the first voyage of Christopher Columbus, I want you to read it again and just put in the chat box yes or no if it makes more sense to you now that you know what it's about. Okay, yeah, because now we have a context. We know what the sentence, an egg, not a table, correctly tipped correctly typifies this unexplored planet. We know what that is. We know who the three sturdy sisters were. And so it's just a demonstration. Okay, yes. And somebody said no. Um, and it's true that you have to know the story of the Christopher Columbus when he, sailed to the New World. He mischaracterized it, but anyway, yeah, you have to know the story, and if you do, then you know who the three ships are, and that's a very important point. That some of our students, if they don't have the background for our courses, then even the strategies aren't going to make a lot of difference. But here's the reference for that if you wanted to see that. And so just briefly, this SQ5R survey, come up with questions, read that one paragraph at a time while summarizing in your own words, and you can teach them to record or write. When they get to the end of a section, review that, and then the last hour is for reflect. Are there any other remaining views that need to be taken into consideration? And this is just an email that I got just this week from an admissions reviewer. And this was a text that a physics professor had sent to had put in this young lady's letter of recommendation. She wasn't passing exams. She was just reading the textbook more like a novel. And so this teacher taught her the reading strategy that we just talked about, and it worked. Not only did it turn her around in this class, but she applied the same technique in all her other classes and saw her grades go up, and she's found confidence. Now, that's the other thing that these strategies will do. Students will gain confidence because now they know that their learning is within their control. Dana, physics student, 54, she was about to drop out of physics. One session, she went from memorizing formulas to solving problems with no external aids. These were her grades. She had a 4.0 that semester, and she is now a practicing medical physicist. And so there's a way that we can teach students to get the most out of their homework instead of just flipping back in the chapter to find examples of the problems that they've solved before. Study the information before they look at the problems or questions. And then when they get to example problems, most students are skipping the example problems. And so we can teach them how to use the example problems as a learning device and just work it without looking at what the author did. If the answer is correct, then they can look at what the author did. If it's not correct, then try to figure out where their mistake was made. And that's just the examples. When they get to the actual homework problems, then treat those as if it's a test or a quiz, speed it up a little bit, because many students run out of time on a test or a quiz, not because they couldn't do the information, but they're just going through it really, really slowly. And this is Dana. She's a practicing medical physicist. Now, you're going to get this whole PowerPoint presentation, and Dana actually recorded the information about how this really helped her. And so you can share this with your students. You can listen to it after you get it. Okay, and so now what I want to do is a real quick activity to show you why it is that students can make such a rapid and immediate improvement. So on the next slide, there are going to be a series of numbers. I want you to first find the number 1, then locate number 2, then find the 3, etc., etc. And put in the chat box how the highest number you've got to, not the biggest number you've seen. 80 is the biggest number on there. But when you find them sequentially, the biggest number you've seen. So let's start finding the numbers now. And stop. So just put in the chat box the biggest number you found. Okay, yeah, 8, 11, 6, 8. Oh, yeah, most people get in single digits, okay? And so now I want you to see a vertical line here, a horizontal line here, and the position of the number 1. And tell me what you notice about how the other numbers are positioned. What's the arrangement of the other numbers? Anybody see it yet? Exactly, clockwise or quadrant, some students say. Yes. And now, let's see, what I was going to do, but I'm not going to have you do it now. Well, no, it's only taking 15 seconds. Okay, so I want you to, now that we know that, I'm going to tell you to start and see how many numbers you can locate sequentially this time. So start finding the numbers now. and stop. So put in the chat box, oh, how many you found this time. 22, 21, yes, much easier. Yeah, I knew that some people were just finding the biggest number. That's why I said, okay. And so we could do so much better the second time because we knew how the information was organized. And I tell students, you've got to know in your classes, how does the information in chapter 3 connect to the information in chapter 1, etc. Now, we know a lot about learning that we didn't know before. Active learning is more lasting. Teaching students about metacognition is important, and Bloom's taxonomy is important. And most of us that were familiar with Bloom's, just a hierarchy of learning levels, starting with just memorizing to coming up with your own ideas and thoughts. And when I teach this to students, they really get it. And so when I ask students to think back to high school and indicate what was the highest level they had to operate when they were in high school, just put in the chat box what level you think students say. Now, they've never seen Bloom's before. When we explain it to them, okay, yeah, seeing lots of ones. Typically, it's ones and twos. There's some that are a little bit higher, but mostly ones and twos. And then I asked, but now that you've been here at NC State for a while and you've taken a few quizzes maybe, what's the lowest level that you think you're going to have to consistently operate here to do as well here as you did in high school, because you're still capable of doing that? And then put that in the chat box. Okay, yeah, and you're on it. Students will go up. And yeah, and some students who took a lot of AP courses or IB courses, they are going to operate at higher levels. And then the study cycle is something that we really, students love this. It's like a roadmap for what they need to do. Preview before class, go to class, review right after class, do more and focused study sessions, and then check your learning. And we tell students if they can do 2 or 3 of these in daylight hours, another 1 or 2 at night, they will have studied for 4 to 5 hours that day. This student is a student at Emory University. She's a PhD candidate. She said it helped her most. She said it's important to use it every day before finals week. It would really benefit students during finals week. And so as I close, I just want to share with you the story of a graduate student at LSU who was failing the cumulative exams. Students have to pass 6 cumulative exams in a period of 2 years. We give 8 a year, or they're kicked out of the PhD program. He only passed 1 his first year, started working with us, and he passed 5 out of 7 the next year, passed the December exam with the highest score in the group. This is he, Dr. Algernon Kelly. He's the only person I know on the planet who has a PhD in chemistry, but he started every college course at the developmental level. And when he left LSU, he teaches this now everywhere he goes. He's now teaching in upstate New York, and I'm going to end with these 3 emails. October 17th, this guy writes, I'm struggling at Xavier, really want to succeed, but everything is just ending with a decent grade. The kid was pre-med, he was making C's. 1 week later, hello, Dr. Kelly, made an 84 on my chem exam compared to 56 on my first one. Then November 3rd, hey, Dr. Kelly, increased my bio exam from 76 to 91.5. And you see the change in his mood. Hello, Dr. Kelly. Hey, Dr. Kelly. Hey, Dr. Kelly. And so talk about resilience. This is a resilient kid down here. This is not. And he said, ever since I started your study cycle program, my grades have significantly improved. I've honestly gained a sense of hope and confidence. And that's what we want our students to have. My family and I are really grateful that you've taken the time to get me back on track. If we have first generation students, when things go wrong, they don't know how to fix it. Their families don't know how to fix it, but this information can. And so in conclusion, we really can significantly increase our student success. But what we really have to do, this was to a physics group, I'll change it before, physics and everything else. But we got to teach our students how to learn. We've got to emphasize that every student can excel regardless of prior experiences. We can't judge their potential on their initial performance, so we can't let them do it either. We've got to encourage them to implement these strategies and persist even when they fail initially. This is the book for faculty, teach students how to learn. This is the one for students, teach yourself how to learn. These are some acknowledgments. These are some references. Thank you very, very much. And I'll stop the share and turn it back over.
Thank you so much, Dr. McGuire. Do you have time to answer a couple of questions if people have them in the chat?
Absolutely, absolutely.
I think we have a few minutes if that's, if you have any questions for Dr. McGuire, please post them in the chat and she'll answer a couple of them. We have a couple of minutes to do that.
Oh, thank you. I'm getting lots of thank yous. Thank you. And it's fine with me if someone raises their hand and you want to unmute their mic and have them ask a question. That's fine too. How do you reach students with these methods before they are desperate? Find students only come to me for these conversations. Yeah, yeah. And that is a challenge. And I say in the book, and here's the middle and high school, I say in the book that unfortunately what I have found is that it's very hard to get students to do this before they have difficulty. And that's why I say as faculty, I encourage us to give our first test or quiz very early in the semester. Before I learned this, I would give my first quiz or test about 3 or 4 weeks in when I figured I had covered enough stuff to put on a test. But after learning this, I would give at least a quiz within the first week because students have no idea that they are not on their way to an A in our class, just as they were in high school. And so they have to have that wake-up call. And in fact, many times when I do learning strategy sessions for a class, we don't even tell the students that somebody's going to talk about learning strategies because nobody's going to show up because they don't think that this is what they need to know. And so unfortunately, it's very hard to get them to pay attention before they've had that failure. So give them a test or quiz very early, then they're ready to listen. And somebody says, you know, this should be taught in high school, middle school, and you're absolutely right. But the fact of the matter is it's not taught there. And I didn't know how easy it was to teach it in college. I've taught this to well, you saw the graduate school student who was flunking. I've talked to medical school students, dental school students, law school students, divinity school students. Nobody has learned these things. And it's very easy for us to teach it to them at this level. And that's what we've got to do because they are typically not getting it in high school. 11:45 class, fantastic. Some responsibility for how students study because we really put a lot of emphasis on tests and exams. Yeah, and sometimes people even ask, okay, how does your strategy differ with grade level? Freshman level different from senior level? Actually, the concept is exactly the same from, I'm going to say, even elementary school. I've talked to elementary school students who are more in just memorization mode as opposed to asking themselves, why is this the case? Why would it be the case that that liquids are fluid and solids are you can't move them around? And so rather than just concentrate on memorizing, really understanding why. And so the idea is the same. The level of the information goes up. And very often students do worse sophomore level than freshman year level because many times the stuff they see in their first year is a repeat of what they saw in high school. And then it's the sophomore year that they start seeing new information that they don't know how to process. So I've been using it. Okay, I show students the learning objectives. Yeah, that's very, very important. Those learning objectives, tying that to Bloom's video. Yeah, anything we can do to introduce students to the concept that their learning is totally within their control because they don't get that. And I think that I see Diane about to say we've got to move on. But I have had big fun talking with you this morning. And again, thank you so much for all that you do and have a great rest of the conference.